All right, here we go. We've got this little car. We're going to take this car. And what we're going to do is we're going to make some predictions about this car, where it's going to be in the future, right? Not in the distant future. This isn't like a Back to the Future movie sort of thing, all right? But we're going to take this car, and I'm going to ask you to solve a simple problem like this. So here we go. You might want to jot it down. All right, here we go. Here's the type of problem you're about to be asked. Here's what you're going to be asked to do. Place an X on a tile where the RC car will be 4.5 seconds after crossing the start line. All right, so people at home, you're copying that down too, because you can turn this in with your homework. All right, you'll be taking a picture of your homework and all the work that you do for this lab. You're responsible for it. You'll turn it in if I don't make this an ed puzzle. Okay, so we're going to place an X on a tile where the RC car will be 4.5 seconds after crossing the start line. All right, now when the car comes across the start line, it's already going to be up to speed. All right, it's already going to be up to speed. So in other words, there's not going to be any acceleration in this problem. All right? So here is the start line. And then you're going to have a stopwatch, or I'll have a stopwatch, or somebody's going to have a stopwatch. And the car will be driving. Go. 1, 2, 3, 4 and a half. And then you're going to have an X right here in the hallway where you think the car's going to be. Okay? So there's a couple of things. One, what do we have to calculate? What do we have to learn about this car before we can make this crazy prediction, John? We can take this car out in the hall and we can study it and find out it's what? Yeah, we're going to need to go out in the hall and we're going to need to learn, we're going to need to calculate the velocity of this car. Ryan, what's the formula for velocity?
Distance over time.
Velocity is equal to distance over time. And we're going to calculate the velocity of this car in tiles per second because there's already tiles on the floor, right? Because the floor is tile. All right, so we're going to calculate the velocity of this car in tiles per second. And then I'm going to ask you to use the velocity of this car and use the velocity formula to calculate the distance this car will travel in 4.5 seconds. That's a very straightforward question. Does that make sense? All right. Again, for people at home and people in here, we're going to be using this formula basically twice. First, we're going to calculate the velocity, and then we're going to use our known velocity of the car, and to predict where the X is going to be, we're going to use that velocity, and we're going to use what time?
4.5 seconds.
We're going to use, Ryan, you were on it. We're going to use 4.5 seconds, and then we're going to solve for the distance. Does that make sense? So we're going to go in the hall. We're going to watch what the car does and measure it with stopwatches, and we're going to solve for velocity of the car. They're going to take that velocity that we know and put it into this formula. We're going to use the time of 4.5 seconds, and then we'll calculate the distance the car should travel in that time. And then we're going to put an X on the floor in the hallway, and we're going to film what happens and see if we're right. Does that make sense? All right. Okay, everyone at home. Here's our car. It's small. It's not the same car we used the other day. This is going to be the start line, the tile white to red, okay? And what we've calculated is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 tiles. So when we hit this piece of plastic here, the car will have traveled exactly 10 tiles. So you're going to use that 10 in your formula for the distance. So we're all going to use some stopwatches, and we're going to time how long it takes for this car to go 10 tiles. All right, everybody. When we cross here, start your stopwatch. When we hit the plastic, stop it. All right, here we go. Here we go. All right. Below the red button, there's like a pause button. All right, so here's what we got. Here's what we got. To calculate the velocity of this car, it went 10 tiles. And I'm hoping that you calculated it at home somehow, although it may have been very hard for you to see. The time was 2.2 seconds. So you can now calculate the velocity of the car. So 10 tiles divided by 2.2 seconds gives you 4.5 tiles per second. That is the velocity of the car. All right. Okay, so now we're going to take this little red car. The steering is all out of whack on this car, so I've had to do a lot of work with that. We're going to take this little red car, and we know that its speed is 4.5 tiles per second. Okay. So if it starts driving that way, and we let it go for 4.5 seconds, I need you people at home to tell me how far away, how many tiles down the track this car should be in 4.5 seconds. All right, so they're working on it out in the hall right now. And what we're going to do is, we know that the velocity of the car is 4.5 tiles per second. Okay? Okay. So we know the velocity of the car is 4.5 tiles per second. So velocity is equal to distance over time. We want to know how far this car is going to go, and how much time. Now, unfortunately for us, I chose 4.5 seconds. So it's just a coincidence that we're going to have velocity is equal to distance over time, and the time is also going to be 4.5. That's a bummer, but that's how it goes sometimes. So if we're going to solve for this d, we're going to have the time times the velocity will give you the distance, okay? So 4.5 times 4.5 will give you the distance. So we believe this thing is going to be 20.25 tiles down the track. Now, if you look at your units, the seconds per second times seconds cancels out, and the only thing you're left with is tiles, so 20.25 tiles. All right, let's go see what happens. So here's what we've done. We took the car, here's the start line, and we counted way down here. Will you follow me down here? Mm-hmm. And we calculated all the way down there. That is 20.25 tiles away. Is that right? Did he count right? I don't know if we can trust him. That's a joke. All right, are you ready? Here we go. We're going to do it. Now, I need you guys to get your stopwatches out. When I cross this line, you're going to hit go.
Or when you cross it, or
Yeah, right when I cross the red and white line. That's
or when
the
you
stop
hit
line.
it.
When the front bumper crosses the line. All right? And then I want you to yell now when your stopwatch says 4.5 seconds. Does that make sense? Ryan, come down here and film from there.
Got
Okay?
it.
Here we go. Everybody ready? You ready to start? Samantha, can you yell it loud for me? I know you don't like to yell. Can you be loud?
Yeah.
All right, here we go. Ready? Seemed like the car was going faster that time. All right, let's pause it for. Well, unfortunately, we overshot it a little bit. We expected, this is the start, we expected the car to be 20.25 tiles down the track, but actually the car was more like 25 tiles. So the next thing I'm going to ask you is, what was the actual velocity of the car? Velocity is equal to distance divided by time, and the car went 25 tiles in 4.5 seconds. So what was the actual velocity of the car if it went 25 tiles in 4.5 seconds? Here's what we would do. Velocity is equal to distance over time. So very simply, we would say the car went 25 tiles in 4.5 seconds. You take your calculator. You say 25 divided by 4.5, and the actual velocity of the car was 5.55, or we'll round it off to 5.6 tiles per second. And that's pretty far off from what we got originally, but that does happen a lot of the times with these little remote control cars. After you use them once or twice, they start speeding up, and that car has been sitting for, you know, a year or 6 months or something, so that's how it works. So we did a good job. I do believe that your measurements were good and that the car just actually went faster in the second test. And the reason I believe that is it happens to me sometimes. So if we did this again in another class period and I warmed the car up, we may get better results. So there's your first part of your lesson today, place an X. So now if you have a problem like this, you'll be able to solve it. Does that make sense?